malware behavior, and then I'll do some more kernel debugging stuff. So here's the malware behavior. So one common type of malware is downloaders and launchers. The downloaders are small, typically programs that download another stage. Metasploit is a very common example. The meterpreter is typically done in 2 stages. A small thing, and when you run it, it downloads more. So it'll use the Windows API, URL download, or something like that to download a file and then execute it. Launchers prepare another piece of malware for execution. So typically the malware is there hidden in an unexpected place like a resource section. And this is the technique I used to get past antivirus for years. You would load the data in RAM as data and then execute it as code. And that would typically fool antivirus. Then there's backdoors, which is what you typically want. It gives you remote access to a victim machine. The simplest kind of backdoor is just create another user account on the machine, but typically you want a remote connection too, so you want it listening or sending out beacons on a port. Typically, you use reverse shells that send out beacons, and they'll typically send out some kind of common traffic, like on port 80 or port 443 or port 53, to mix it in with the existing traffic. And so you'll typically have the ability to execute arbitrary commands, manipulate the registry, and so on. So you have a reverse shell. You can just make your own with netcat or ncat on Windows, and you can start listening on port 80, and then here you can execute a command down here, so you can get this would be the command and control server, and this would be the victim, so it does ncat -e. This is a famous dangerous switch in netcat, where you make a connection and then you execute a command and connect it to the network socket. So it's just designed for this purpose. You execute CMD, connect to a remote server on port 80 and execute CMD, and now this server that's listening on port 80 can execute commands. It's the simplest way to make a reverse shell. So here's the way you do it with Windows API calls. You create a process, create a socket to the remote machine, that's the external IP address and port number, then tie it to standard input output and error for cmd.exe, and then run cmd.exe with the window hidden. So now you're taking commands from the network socket and you're sending the output to the network socket. All right, you can make it multi-threaded. That way you have one thread for standard in and one thread for standard out. And that's what remote administration tools do. So you infect machines, then they go to servers, and somewhere the actions are being fed into them. So you have a collection of compromised hosts called bots or zombies. That's your botnet. And the botnet contains many hosts. Rats control fewer hosts typically. They're typically one at a time. That's the main difference. Rats are for targeted attacks, and botnets are used in mass attacks. Remote access Trojans, they call it. And then credential stealers, things that will try. One thing you can do is wait for people to log in and steal key presses, or you can dump the stored data like password hashes. Gina is an old technique used by XP to handle logins, and you can implement that with MS Gina. And so by hooking MS Gina, you could steal authentication material. You'd put a tool in the middle like FGina, which is an attack tool, and it would then intercept the authentication signals that were used to log in. However, now Gina is gone, and now it's replaced by something called credential providers in Windows Vista and later, and there is possible to do a similar man-in-the-middle attack on them, but it's less powerful. There's one here, you end up having 2 login buttons and it only steals passwords from the second set, so you'd have to add code to filter out the first set. So Microsoft made it a little bit harder with their latest version. One technique that has never changed since 1993 is hash dumping. Microsoft has never improved their hash function. Their hash function is 1 round of MD4 because it is so old, MD5 had not been created yet. It's really a sin and a shame. Linux passwords and Mac passwords are literally 1 million times stronger, but that's the way it is. They did quit using the LM hash, which was even weaker, and now they use the NT hash, which is 1 round of MD4. So it's pretty appalling. And one of the many things about it is you'll notice if you have 2 accounts like backdoor and backdoor 2 with the same password, they will have exactly the same hash. There's not even any random salt added before you hash it. So this is just extremely out of date. Linux updated their system to avoid this kind of hash in 1975, and Microsoft still never got the memo. Anyway, so you can dump these hashes and you can crack them offline. They're pathetically easy to crack. You can crack most of them by just Googling them, because for more than 20 years, everybody's made dictionaries and put them on the internet. So if it's a password anybody cracked before, you can just look it up on the internet. And if you do want to crack it, you can literally try millions of guesses per second on a single processor. It's amazing. Anyway, so a lot of tools that will dump the hash off the Windows machine. And once you've got it, then you can try cracking it by just trying a lot of passwords until you get in. pwdump is one of the tools to steal hashes from the security account manager. It injects a library into another process. LSASS is a common target that has high privileges and access to the hashword hashes and other high privileged things. So it injects an LSA extension .dil into LSASS that it calls get hash, and that uses undocumented Windows function calls to dump out the hashes. And as I mentioned, I think last time, since you have WinDebug, you can debug the kernel. You can totally figure out what all the API calls, even the ones that Microsoft doesn't document. All you have to do is read the assembly code to see what they do, and that's not really that hard. So that's why plenty of attackers can use these undocumented features. All right, and there's another variant here that used various other DILs access added into it, and extracts hashes with something called SAMI get private data, and decrypt them with these undocumented functions. These are all undocumented functions. So here's the unique API calls: load this DIL, call the SAMI connect, call the system function 25 and system function 27. You know, it's what you do to get them. Remember, the Microsoft, instead of making the hashes stronger, they protected it with a layer of symmetric encryption called syskey encryption, but that key was found long ago, so you just have to decrypt it. That's why there's a layer of decryption involved, and then a layer of hash cracking. Pass the Hash Toolkit is a popular hacking tool that also harvests the hashes. It uses different API functions, the LSA, enumerate logon sessions, and so on. But it's pretty easy to steal the hashes from Windows systems. There's a bunch of tools. My favorite is Kane. Used to be called Kane Enable. It's a GUI tool. It works very well. You don't have to do anything complicated. You can steal the hashes off Windows system very easily with it.
It's KAP.
What's that? No, CAI. If you want to, yeah, Kane. Hacking tool at oxid.it. Yep. Yeah. Very famous tool. All right. Let me check for comments. There are none. All right, let's try for Cahoots. Should be some of them. Let me close a few of these extras. And there we go. So 11A. All right. Kane's easy to use. All right, so poison ivy, what's that? Don't remember seeing it on the slides. I guess it must have been there. famous remote access Trojan from the Windows XP days. All right, which one will store malware in the resource section? Azure launchers, all right. All right, which one will cause the infected machine to send a SYN back to the attacker? That's a reverse shell, what you almost always use because it bypasses the Windows firewall. All right, what technique is no longer possible in Windows? That's Gina interception. They no longer use Gina. And which one puts a DIL into LSASS? Yeah, more than one of them. I think the top two do for sure, and Gina might also. All right. So, you want to keystroke logging, you can do it from the kernel. That would be part of a rootkit typically, and what it'll do is act as a keyboard driver. User-based keyloggers will use the Windows API, and they'll do it with either hooking or polling. Hooking is where you use the set Windows hook API call to hook the key press functions. You can always, hooking is where you add an extra thing that will run along with an event. This is very commonly done by things like antivirus programs. It's part of Windows operating as intended. And then there's polling, where you can get the instantaneous state of the keys at a moment in time, and you'll have to do this frequently, like many times per second, to track down each key press. So get async key state will identify whether a key is pressed or unpressed. Then you can identify the foreground window, so you loop through all the keys, and then record the information you find, and then sleep, and then do it again. So this is a polling keylogger. It will call the get foreground window to get a window, then call get the key async key state and get all the different keys, and then that's what it'll do, and then it'll sleep and then try it again. Your key presses always go to the foreground window. So you can usually identify keyloggers by just looking for strings like this. They usually have to somehow record these important keys, and so you'll see things like that. All right. Then persistence mechanisms, so you can survive a reboot. Here's three of them. The most common one is probably the run key, where it just automatically launches anything in the run registry key. You can also use app init DILs, winlog notify, service host DILs, other ways to make things automatically launch. Or you can Trojanize binaries, or you can put DILs in a place where the wrong library will be loaded because it's in a directory that's searched first. So some automatic process will load that library, and that'll be your malware. So here's one of the run keys. There are many others. Procmon will show the registry modifications when running malware, which is nice, so you can detect all these things. And so here's process monitor detecting this thing, setting registry keys. You see it, software classes and class ID, and here's more setting things here. So you see it does pick up the registry operations that happen and the file system operations during a program run. So that's why it's a very good program. App init DILs are loaded into every process that uses user32. So it's another way to easily make it automatically launch malware as soon as anything loads that interacts with the user. And you often, malware will call DIL main to see what process it's in before launching a payload. That's another thing. You can control which process launches it if you want to. Beginning with Vista, though, it's disabled. However, beginning with Windows 7, it supports code signing, I guess if you turn it back on. But anyway, in modern versions of Windows, it's supposedly completely disabled if you have secure boot on. But not everybody uses secure boot. So, you know, it's probably still useful for quite a few machines. And WinLogon Notify, these DILs handle WinLogon events. So when things like logon, lock screen, and so on happen, then you can tie malware to that so it can steal credentials and launch automatically as soon as you log in. Service host is the process that runs most of the background services. You see a lot of them running, and the groups are defined here, and so you can just add another library to there, and it'll be automatically launched during the startup of the machine. Process Explorer will show them. You have all these pink things are service hosts, or most of them, and if you hover over one, it will show you all the services being run by service host, typically 10 or more on the same one, so you can just add another one to this list, and then your malware is running in service host. You'll find them in the registry. Here, current version service host, here's where you define the groups, and you can define what's going to be launched by each of those groups. So they all contain parameters, and so here it is. The parameters will tell you the location of the library that's going to get loaded. So you can just create registry keys to automatically load another library. And they're in groups. Then you can do that. Put yourself you can override a non-vital service or add yourself to an existing group. This is easy to do because Windows is huge. It's the all-purpose operating system, so it's got hundreds of things running that you are not using, that are often even broken and you don't care. So overriding one of them is usually not going to matter. All right. So you can detect it by monitoring the registry, or you can look for service functions like create service in disassembly. That might be a way to detect it. All right. Let's try another Kahoot. 11B. Thinking about what you said, if Llama is based on filtered data, then the opposite is Grok AI from Elon Musk that is explicitly not filtered. So, anyway. so which one runs as a keyboard driver? Those are kernel mode keyloggers. Good. All right. Which one uses get async key state? That's polling, checking to see the current state of the keys. All right, which of these depend on registry manipulation? Yeah, the two ones on the bottom definitely do. I'm not sure about winlog on notify. All right. All right, which tool records all registry modifications? That's Procmon. Process Explorer just shows you the currently running processes. It doesn't show you the actions of a process. All right, which item is loaded in every process that loads user32? Those are the AppInit dills. All right. All right, so the other thing you can do is patch the system binary to modify it. That would be nice. A dill would be a target. And then you typically modify the entry function to go run some Trojan code and then go back and run normally. So it maintains the functionality of the dill. It just has extra functionality added by the malware editor. So you might have original code, would enter here and start doing this stuff. The Trojanized code would now jump somewhere else and then later come back to pick up where it left off. Then dill load order hijacking, we talked about the order in which things load, a directory from which the application loaded, the current directory, the system directory, and so on. So if your real dill is someplace like Windows System 32, you can put a fake one with the same name in one of these locations and it will load first. There's a known dills key that will prevent this, has a list of specific dill locations. So if you have it in known dills, that will protect it. It'll force it to load only from the official place, see Windows System 32, and not anywhere else. Explorer.exe, this is what used to happen to Windows NT. It actually would launch by running Explorer, and it would then hunt for Explorer. So you could put another executable somewhere, and then when you log in, the other thing would happen. So it lives in Windows, and it has a Explorer.exe has a DIL that is not protected, so you can put a malicious ntshRui.dil in Windows, and that'll be loaded instead. There's a lot of vulnerable DILs. Explorer.exe has 50 vulnerable DILs. It's all over the place. Mike, this is extremely common. I remember being very frustrated when I started teaching Windows tech support. When Microsoft, every version of Windows, they announce these new protection features. When you actually check, they only turn it on for about half the code. So they're almost useless every time. I think it's because they have a huge burden of legacy code. Anyway, there's a tool from SANS that will look for this. Search for DILs that appear multiple times in the file system, which is a pretty good clue. There really should be only one copy of those system DILs anywhere, so that's a tool that might help detect this attack. And then privilege escalation. You typically, the way you take over a machine is you send somebody an email or an instant message and they run code or click a link. Now you're running as a local user, but you want to elevate to administrator, steal credentials, and then try to become domain administrator. So now back in the old days of XP, everybody ran as administrator all the time, but not anymore. So Metasploit has privilege escalation exploits, and there's a lot of ways to do it. SED bug privilege are things that, if you are the local administrator, then you can escalate to system with things like the debug privilege. So here's how malware obtained it. It's going to token adjust privileges, open process token, and then add debug privilege to the token. So that's one way to do it. If you have the administrator rights, you can add that privilege to your token and adjust token privileges. So that's another way to do it. There's a lot of ways to do it. If you use Metasploit, it has about 6 or 7 ways to escalate, and they work almost all the time on every version of Windows. So the next thing is how you're going to cover your tracks. You can hide files, network connections, and processes with a rootkit. Kernel mode rootkits are more powerful, but they're not that common anymore, so user mode rootkits, as covered here, are probably the most important topic these days. You can do it with import address table hooking. For any PE file, that's an old technique, but you'd see it here. So you have a legitimate process, and it has an import address table, and so you modify it with a hook. You take the rootkit code and add it to the import address table, so it will have an unusual function there that's pretty easy to spot. And you can do inline hooking, where you actually modify the code in the API contained to the imported DILs, changes the actual function code. This is more advanced. You have to be a pretty good programmer to do this without breaking the DIL. So it's not as common, but it's therefore not as easy to detect. So let's try 11C. All right, this malware which one adds malware to an empty portion of a Windows complex? this is how you do it. These things are called code caves. There used to be a code cave tool. You run against a executable and it will find the blank areas that are not used. There are blank areas in compiled code where you can just add extra assembly code and jump to it. That's how you do the Trojanizing system binaries. All right, what registry key prevents load order hijacking? There's the known dills. All right, which one had 50 vulnerable dills? Explorer.exe, the main process that draws the desktop, the one that is always running. All right, what hacking tool makes privilege escalation easy? Exploit, the main all-purpose hacking tool you use and learn if you take the hacking classes. And which one will change function code, not pointers? That's inline hooking. It requires you to actually understand and modify the assembly code. Let me stop this.